I'll be okay with that. So,
ready to connect the AT&T Wi-Fi.
Go to a non-secure website.
what's that?
Go to a non-secure website.
Oh, okay. Then you just have to.
Try Facebook.
Well, if not,
Or like Apple.
I was going to try to run it all in the browser, but that's okay. I have it local. And I was going to go to GitHub and show the code as we go. But that's fine. So, well, let me get started. So, name of this is Why I Like React. So I guess there's going to be a little bit of opinion in here, but hopefully by the end you guys kind of see why I like React, and also hopefully I present this correctly, and you guys understand and follow along. All right, so about me, I've done a talk before, but I work for Beacon Health System, which is a health system where Memorial and Elkhart came together, and so this is a system above that. So I'm a programmer there. We do like .NET, do some websites, so I do some JavaScript and some Python, and we also have some proprietary stuff there, but whichever one I like is kind of what I'm doing lately. I'm doing a lot more JavaScript. I like JavaScript over time. Recently, my wife and I, we just spent 2 weeks in Europe. So that's something that last time I spoke wasn't true. So if you have any questions about international travel, ask me. I have some practical stuff about traveling to like Italy and a couple other places as well. And I like React. So let's go and get to the meat of this. So what is React? It is just the UI, just the user interface. Anytime there's a new library or a framework, the question is, what's its competitor? And with anything, especially any JavaScript framework, you're going to say, does it compete with Angular? And the answer is React doesn't really compete with Angular. Angular is a complete framework of how you build an application. React is really just a library. If we're talking MVC, it's just the view. It does nothing with models or controllers. It's just the view. If you do want to compare it, an Angular directive is very similar to what a React component is. So if you know about Angular, that's kind of your idea of where React fits into your JavaScript when you build it. Now we're not going to spend a lot of time comparing against like what Angular does versus React. We're going to focus a lot, just pretty much on React. So where did it come from? Now I don't know the exact political structure, but I'm guessing React probably came from Instagram, because right now all of Instagram is built in React. And of course, when Facebook bought Instagram, then I'm guessing somewhere along the line, somewhere in Facebook, they're like, okay, we like this project, and if Facebook has started putting their weight behind it. It's an open source project. They have Facebook developers working on it. So there is some, pedigree maybe behind it. So there's definitely people working on this and advancing it. Facebook has started using it for their commenting and look back editor. Khan Academy uses it. I kind of put a little image there. You can see the data React IDs. That's pretty much how you can tell something is using React. And we will, as we build stuff, we'll look at the HTML and see this as well. So it definitely can handle large sites. So this is kind of the crux of my talk. Why use React? If you're using Angular or Knockout or Ember or any of those other libraries, why even look at React? And so hopefully by the end of this, I've at least explained these 3 things. So React is kind of a whole new paradigm. You have to kind of think in React. You can't think in the same way you've thought about UIs before. Kind of the same way where before, if you're using jQuery and you're just using selectors and you're just modifying the DOM manually and you jump to something like Angular, it's kind of similar, where you have to completely go back to how you're thinking and say, we need to design this differently. So that's what React gives you. You have declarative components. When you look at the component, you should be able to tell exactly what it's going to do and very quickly. Hopefully you're not building a ton of spaghetti code and you can't tell what this will render to. When you look at it, you should know exactly what's being put on the DOM in your browser. And this is kind of wrapped up with these other two, but it simplifies how you think about your UI. Which, as programmers, we know when you have this huge thing and you have to think about, when I change this, how's it going to affect this, this, and this, and this other thing? So React hopefully allows you to simply think about your UI in a different way and in a simple way. Okay. So we're going to kind of follow the React Quick Start. You can just Google this and download it. You can use Bower if you want to download it. If you're using NuGet, there's NuGet React packages. So this just has the actual React and using it. So of course we're going to start with the hello world. So we're going to introduce it because I'm guessing not many people here have actually built anything in React. So we're going to build a couple quick components right now just so you have an idea of what React looks like and how it works. So to do it, we need a React component. And then that is a lot like the Angular directive, a web component. It encapsulates behavior and the look of what you're building. The only thing it needs is a render function, which makes sense. You're going to render it to the page. And that render function needs to return one element. You can't return 2 or 3. And we'll kind of see why you only can return one element. But if you do it, React will tell you, hey, you can't do that. So it's actually really good at giving you warnings when you're doing stuff you're not supposed to. So if all you did was render a static page, this would be worthless. Why not just do HTML? So that's where data comes in. And in React, use props and state as data. And again, we will jump into this further as we go through the talk. But that's how you put data into an element so you can dynamically change how it renders. And then JSX. So if you've ever looked at React and went to the page and you saw JSX, this is probably the reason you immediately said, no, I'm not going to use React because of this. It's like a mix of HTML that you put in your JavaScript. A way to think about it is, usually with Angular, you're putting JavaScript in your HTML. This is pretty much the exact opposite. You're putting HTML in your JavaScript. So that's what JSX is. Now, it's not valid JavaScript, so it has to be transformed. In our examples here, we're going to load up a script that does it on the fly in the browser. But if you're doing production, you're going to put this in a build system like Grunt or Go, and you're going to transform all your JSX before you serve it. But for examples here, we're just going to pop it in and do it right in browser. So we're actually going to look at our first example, some actual code, hello world.html. So let me grab that. And this is out on GitHub, all this code here. And I'll send the link to Rob so you can see that. Do I need to make this bigger? I'll zoom in a little bit. Okay. So this is pretty much just simple HTML. You see we have React pulled in. That's the JSX transformer. That's what's going to transform our JSX in browser. We have a div here, React root. So when you render, you have to pick a point that you're going to hang all this React off of. So that's just our root that we're going to put our component is going to render off of. And you can see we have text, script, text.jsx or /JSX. So this is how the JSX transformer knows that this right here is JSX, and it needs to compile it into JavaScript in the browser. And also, if you load a JSX file, like if you had it on your backend, this is how your build system would know to turn these into JavaScript. So, hello, that's going to be our component, and you just say React create class, and then you just pass it a simple old, well, I guess you could say a plain old JavaScript object, a POJO. So you pass it a POJO, and we have a render function, and you can see right there, it's pretty much just HTML. We're going to say put an H1 element in here. You can give it an ID. Now, you notice right here, you're already seeing a little bit different. Class is a protected word in JavaScript, so there's class names. So there's a couple attributes that you do have to know when you're building these. But for the most part, you can just use the HTML attribute. And then here's the content. So hello, and then we're going to use this props.name. So we can use this because it's just a POJO. So it's just a plain old JavaScript object. Props will exist, and that will be a property off of props. Now to put it on the page, we tell React to render it. So there's our component. It's going to be hello, because that's the name of our variable we created. So it's a hello component. And then that attribute name, that's passing in a prop to it. So this should say hello React.jsx, and then you just get an element, and that's where it's going to render off. Does that make sense? So we're going to go ahead and open this up. And there it is. So there's React rendering our hello component. We will go ahead and take a look at the HTML here. So here's our React root, and then you can see it added an H1, and then you can see it added the ID in the class as we told it to, rendered exactly how we expected, and then you kind of see how it rendered 3 spans because we created, we interpolated that string. So hello was one part of the string, then the JavaScript this props.name was a part, and the exclamation was a part. So it chopped this up and it turned it into the H1 with then the text in it. But as you can see, it rendered exactly what we were expecting. Now, so I'm going to comment out this, and we're going to look at this. So this is pretty much the same thing, except instead of using JSX, we're actually going to render it with JavaScript. So this is pretty similar to what the JSX transformer is going to create for you. So same thing, we're creating hello.js component with React create class, pass it in a POJO, and then we're saying React dom.h1. So that's going to create an h1 element for us. And then the first parameter we pass in is going to be an object with the attributes. So you can see it maps exactly to what we were passing in with JSX. So if you want these parameters on your element, you just pass it in. For example, if you had an input and you wanted a placeholder, you would just create a placeholder property and then give it that value, and it would render with it. And then we pass in the content. So we have the element, first parameter is the attributes of that element, and then the next parameter is the content. So this is very explicit, where before we just put the string in and it passed it in. Here we're being very explicit that we want hello, comma, space, and then we want this prop's name, and then an exclamation mark. So it'll put all those together. Now as we go in, you can use this array syntax. Like let's say you want to render an unordered list. You would pass an array of all the list items you want inside, and then that would render it. So we have this, I saved it, I should be able to then refresh this page. So you see the same thing output. Here we have ID of hello.js, class of hello, and it rendered exactly. So using straight JavaScript is just being more explicit about what you're doing. And actually, at the end of the day, that's what you're actually going to be running in the browser at the end. So it's our first hello world. So as I talk about more things you can do with your component, you at least now have an idea of what a React component looks like. All right, so, okay. So how does React work? We put some stuff on the page. Now, again, it's very simple and essentially arbitrary, but we'll get into more advanced things. So, for example, does React have two-way binding? When we think about Angular, these other things, how are we going to update data on the page? Okay, stop. You're not thinking in React. This is not how React works. Okay, there is no two-way binding. React re-renders the entire DOM on every state change. So there's the two-way binding. When a value changes, that tells it it needs to re-render, and it's going to re-render your entire DOM. So, next question, isn't that slow? Yes.
So hold on, just to be clear, that's your entire DOM, not just the React connect.
No, well, yeah, I should have been clear. The React DOM.
Okay.
Yes, good question and good point. So it's just the React DOM that's rendered, not your entire DOM. The entire React DOM. Yes, that's very slow. We're talking reflows, we're talking lots of issues of rebuilding your entire DOM. But that's why React uses a virtual DOM. Now don't confuse this with the shadow DOM. A shadow DOM is when you have like a web component and you kind of hide another DOM inside of like an element. This is not the same. So you've defined your components and it's going to build a DOM tree in memory. So this is why we need one element to return from a render. You can't have a tree that has two trunks. So at your very root, you have one render, and then you're going to have one element, and then everything then will flow down from that. And each time you have another component, you have another point where just one element is returned. So you have a tree that just goes down, that's your entire DOM. It's going to take that, compare it to what's on the page, and build a diff. So if it's only going to update one letter, that's all it updates. If you need to add 3 divs, it just adds 3 divs. So it minimizes your reflows and what's built. So this is really where you need to start thinking differently in how React builds it. So this hopefully is starting to open up a little clarity in that every time you render, your state will be in a point that you know it is. So if you know you've updated this state, when you get to your render function, you know your state will be set. And so you can render assuming all of those variables are set. Okay, so we'll kind of get into, we'll kind of look at that. We'll look at some redrawing when we build some more complex components. But the long and short of it is React re-renders the entire React DOM. All right, so now we're getting to data, props. These should be treated as immutable properties. When you have a component and these props get passed in and they need to change, they don't change inside the element. They have to be passed back in from a higher element. So when these come in, they're immutable property, you don't change them in place. If they change, you have to re-render the component. There's no mutation over time. At step 0 to step 5, if they haven't been passed in, they're exactly the same, and that's how you should treat them. And then that's where state comes in. So if you have an application with no state, again, you just have a static application, which doesn't do anything. So you need state. So if you need to mutate state over time, that's where state comes in. There's a nice little React function called setState. You pass in the new state, and then that tells React that, oh hey, state's changed, I'm going to kick off a re-render, and it re-renders everything. So Facebook, the React programmers have said, don't modify state, treat this as immutable as well. So how does that change? You do things like, if you have an array, you make a shallow copy of it, and you modify that copy. So that React will take it and compare the current state with that new state. Now, if you modify it in place, there's no way that you can compare old state to new state. So this immutable idea is going to start coming in more and more as we build more complex components. And immutability is kind of hard, especially when you're talking like JavaScript, in which you can just modify your objects at any point in time in any way you want. So you have to be very clear about how you're changing your state and how you work with your state as well. Okay, so when do you use them? The answer is you should probably be using props as much as possible. You want to make as many components as stateless as possible. So a good paradigm is you have one high-level component that has state that then is passed down. So you pass props down to all the components underneath. And then if anything happens, you pass what happens back up. And we'll look at that. But for the most part, it's kind of a good rule of thumb that use as few stateless components as possible. Make everything use props and treat them as immutable. Data flows down. Okay. So now we're going to look at some methods you can call. Like I said, we're going to write some code here in just a couple slides. Because this is a library, we can actually look at pretty much everything you can do in React like right now. This isn't Angular where you have a huge API documentation. Again, this is just a very simple view library. Render, we looked at that. That's what builds the DOM. Get initial state. So if you have a state, you need state at step 0. So this is how you get your initial state when you render it the first time. Get default props. Kind of the same issue with get initial state. If you have a prop that your component relies on, you can set a default here. Although I would say that's kind of an anti-pattern in that if you have a prop that's needed for render, you probably should pass that in and not set a default for it. But that is there, so you can use get default props. And then prop types is an object that you can create to say, I expect these props, and if I don't get them, I'm going to throw a warning out. And you can say, this prop type should be an array. So if you have a component that needs props, you can use this to kind of tell the developer, hey, you need to be using this prop when you render. Okay, now lifecycle methods. So over the course of a React component, you have component will mount, which is pretty much your initialization. So if you need to wire anything up here, this is the spot to put it. Component did mount, that means it's on the page. Component will receive props. That means the props are changing. Because again, you've rendered a component and now your props change and they're getting passed back down from a higher component. This will kick off. Should component update? Now this is an interesting method. It allows you to tell React not to render your component and everything underneath you. So you return true false here. So if you say, should I update? React actually just takes you out of the tree to even determine if there's any diffs. So it's kind of a way to speed up how you're rendering. And what you get in is you get the old state and you get the new state. Again, if you haven't treated that state as immutable, these will be exactly the same and you'll probably create some bugs. Because then you can compare them and say, well, my state for how I need to render hasn't changed, so I don't need to re-render. So you can just turn yourself off, and in React will then not even consider you for the building of the virtual DOM or for creating a diff. It just says, you're fine on the page, I'm not even going to worry about you. Now again, if you implement this incorrectly, you're going to get weird bugs, where you update something, and then you expect the DOM to update, and it doesn't, because you said, don't update. And then now we're getting kind of on the backside, component will update, when it's going to be update, then it did update, and then finally component will unmount. So we had our init method, which component will mount, and in component will unmount. So if you wired anything up, this is your spot where you unwire. And that's pretty much the methods and the things that you can actually do in React. That's it. Okay. Events. Event delegation is built in. If you don't know what event delegation is, this is the best example I can think of. So if you're back in the days of jQuery, and then you build a selector, you have this unordered list, and you have a bunch of list items, and you put a class of click me on all of them. And you put a selector, and you say on the click of the class click me, call an alert or log something to the console. And you have 5 list items. So you click each one, you get a nice console. What happens when you add a 6th item?
It doesn't have the event handler.
It doesn't have the event handler because that query was at a certain time. You either need to re-query or do something. A better way is event delegation. So instead of putting the event handler on the list item, you put it on the unordered list. So the event will bubble up off of the list item to the unordered list. And then when you listen for the event there, you say, was your target the list item? And if that answer is yes, you say, okay, I want to handle it. I want to do that. So what's nice about that is you add 1 event handler. That's it. You don't have 5 event handlers. Because if you did it the jQuery way, I shouldn't say the jQuery way, because you can use jQuery in much better ways than that. So the incorrect way, by adding it to each element, then this is much more robust. You add a 6th element, it works. You add 10 more elements, it works. So React gives you event delegation built in. So as you add events to elements, they're actually added to the root component. And then those events just bubble all the way to the top. And then that says, okay, you were this element, I need to handle you with this function. So you get event delegation out of the box. So you don't have to worry about doing it incorrectly. Now, when the actual syntax is going to look like the old HTML attribute, it's actually onClick. And then we'll look at the HTML, it doesn't actually add an onClick. It just registers a callback to the component. So it may look like it's the incorrect way of doing it, but this is the correct React way. So when you're looking at what you want to do with the events and the handlers, you can have them modify the state internally. We're going to look at that. We're going to build something that does that. You can have them pass down from above. We can do that. You can fire an event. You can create, you can use something like postal, something that creates a bus, and you can just say, hey, someone click this, and just, I don't care who listens to it. Then you just get observers that do that. We don't have any examples with that, but we do have for the first two. Okay, so we've looked at all these things, so now let's actually look at some code where we implement it. So if you think back all the way to props, that mouse doesn't connect. So this is our immutable data that we're going to pass in. So we have this, we have a little MD5 library because we're going to use Gravatar. And then we're just going to pass in a username, and we're going to build a Gravatar URL, and then put it on an image. So as you can see with this image, again, when you're building, now this is not the JSX, but you can just imagine that you just put IMG, and then you'd put each one of these properties with this value. So here it's very explicit. We're using JavaScript. We're saying, I want an image element. The title is props username. The alt is props username. And then I'm going to call build Gravatar with the username and the size to put the source. And then, of course, because it's a image, we want no content. So you just pass it in. So this will render an image that uses that username to go to Gravatar and return an image from it. So this will render exactly how we expect. Now, with props, there's no built-in way to fire off to say re-render. So I have a set timeout here, which I think I have 5 seconds on it. Yep. So after 5 seconds, it's going to go in and tell React to re-render over the top. So this is how render changes props. You have to re-render them. There's no way to change them in place. So this isn't going to be that exciting, but oh, you know what? So that's because I don't have an internet connection. So you can see that actually changed the properties there. Does that do if I just do .com? You said I just have to go to HTTP. All right, what am I going to worry about?
Are you connected to
I think
AT&T
I'm
Wi-Fi?
Yeah, AT&T, I think. All right, well, but you guys saw that what's that?
Google.com should have, unless that redirects you now.
All right, well. So
Try turning it off.
Restart your machine 3 times.
So you can see right there, because you have a broken image, and I have the alt set, that it's actually changing the element right there after 5 seconds. So when you're using props, that's how you change a prop. You have to re-render the component. Let's see, what do I have? So simple state. So now we're going to look at a simple component that uses state. It's just going to be an incrementer. So because now we have state, we need state at step 0. So we're creating, we're returning an object with count of 0. So that's our state. And then we're going to have an incrementer where we're going to increment that count and then set state with count to increment. Now when you set state, it'll merge your objects. So you don't have to track the entire state. If you're just modifying one piece of the state, you can just take that and use set state and it'll merge it with the difference in the object. So if you're just changing one part, you only have to change one part. You don't have to pass in all the other properties along with it. React will do that for you. And then decrement does exactly what you expect. It pulls it down. And then we use set state. Remember, that's what tells React, hey, state has changed. You need to re-render because the state is different. And then we have the render function. So we're going to have a div with no attributes. And then we have an array. So we're going to have this state.count. So it's going to put a span in there with our count. And then we have a button. And there's our onClick. So that's not going to add an HTML attribute on click. It's just going to register that callback, this increment. With increment as the text on the button and another button to decrement. And then, as you can see, we're just going to render it. So unlike before where I had a set timeout, and after X amount of time I'm going to re-render the component, this component is going to re-render itself based on this set state. So I will crack that one open. So there we go. I'll click increment, and it goes up. Decrement, it goes down. So there it is. And when you look at this, the render function is you just say at any point along your step with the state, this is what I want you to output. I want you to output the state and 2 buttons. You know, there's no binding anything. It's just clear. So when this renders, you know, the state has been changed, and it's going to put it on the page. Now, if we open this up, take a look at these elements. Just so you're sure, on the buttons, there's no onClick attribute. So it's not there. And also, I'll hit the button here, and then watch the span. You'll see that that is the only element that's actually updated each time I hit the button. You see that? So that's the React virtual DOM working. It's going in and saying the buttons have not changed. They're still static. There's nothing I have to do. The span did, so that's the only part I'm going to update. All right. And then one more, I think, yep, just state. So it's simple state, so now we're going to have a little bit more complex state. All right, so now we're going to go in. We have this user image. Now, if you were to do this and not just with the demo, you know, you'd have a nice directory structure where you had your components, and you'd put, you know, one component per, you'd export it, and you can import, you know, everything that you want. But I'm reusing the user image. It's exactly the same as it was before, so we're not going to see the image, but you'll see the name attached to it. And now we're going to use this user list. So we have a component, and if you notice here, you know, there's no state in here. It's all props. So this is essentially an immutable, simple renderer. You pass it data, it's going to return HTML. You pass it the same data, you get the same HTML. You change it, you'll get different HTML. And then we have this user list. So we have actions here. So here is where we're treating state as immutable. We're slicing it, which will make, you know, a nice shallow copy of it, and we're pushing into that object. And then we're setting that as a new state. So it still has the old state of the array of users, and then it has the new state with a new user added. We have remove user, which is, you're going to do the same thing, except then pop out a specific one set at a certain index. We have a handler. So when you click on each list item, it's going to pull the index and then say remove the user at this index. We have a map user. This is just taking, it just returns a list item based on the user that's passed in. So we have key index. Now, React will complain whenever you build components to say, hey, you need to add a key onto this. It helps it track a little bit with what you're putting on. And for example, if you have a list like this, and you have a key, and let's say you don't use just the index, I mean, because that's simple, you know that's going to change each time. But if you use an ID, let's say you have user ID or something unique for each item, and you say delete the third item, if you don't have a unique index, it's going to delete the bottom and then bring everything up, if that makes sense. It's going to say, hey, I need you to re-render 3, 4, because you deleted 3, I need to re-render 3 and 4, and then delete 5. But if you have a unique index, it can take the diff and then say, just delete 3, and then take that out. But here, that's not going to matter that much because I'm just using the index. So 3 next time will be the one below it will become 3 the next time we render. We have an on-click. We're using bind so that instead of passing in the event object, you get an event object that's just like any other library. You can look at it. It's got target. It has all the stuff that you expect on event object. But here we don't want that. We want the index, so we're binding it, so index gets passed into that event handler. And then we're just rendering the user image, and then there's our props. So for each user, we're going to take the user, say size of 100, and then put that username on there. So there's our get initial state, and this is a pattern that Facebook recommends, that you can use a prop to set initial state, but you should make it very clear that that's what it's for. So don't call it users, call it initial users. So it's very clear that that prop is to build the state on the first render. So we take it and return it. I could have just returned this prop as initial users. So this is the prop types I was talking before. So right here you can say, hey, you need to pass in an array as initial users. Now, it won't necessarily blow up unless, of course, you require that array somewhere and JavaScript blows up. But it will warn you in the console to say, hey, did you know you didn't pass in initial users and it was required? And then we have a render, which, as you can see, very simple. We're going to return a UL, no attributes, and then we're going to map the users using this map user. So each user is going to get called into map user, and it's going to return the list item. So does that make sense, everyone? When you map a user, it's just going to return an array of list items, which will then render as list items inside the unordered list. And then we render it. So we're starting with initial users of Josh. We're going to render it to a React ID. And I have a timeout. So after 1 second, it's going to add a user. Now, this is kind of new as well. I have root here. So when you render a React component, you actually get returned that object you created. So I can save that reference, and then I can use add user, and it will call this function off of it. So saving the reference to the React component that comes out, and I'm calling React add user, and it's just going to use the current date and then create a user based on that. And then every 10 seconds, it's going to add another user. So you can see as well, this is kind of like an Ajax event happening outside of React. So internally, I can click on each list item, and that would delete that list item at that place. And also, in addition to that, the list is going to keep growing. So let's go ahead and take a quick look at that. So there, it's starting with Josh, the first one. So 1 second, and render that. In 10 seconds here, it's going to render another one. We're going to inspect element and go to console. So you can see their Gravatar is failing. So right there is a React. It's saying, hey, did you know you didn't use the key prop on this? So it's really good about letting you know, hey, you should be doing this. I'm going to pull this up, and I don't know if you guys know this, but you can hit rendering and show paint rectangles, and you see that with green. It's showing you the only thing that's added. So every time the new one adds, React is saying, okay, those other ones haven't changed. All I have to render is one list item at the end. And then I should be able to click on each one of these and delete them. As you can see, it's pulling everything up from the bottom. That one just said delete the last one. So again, that's React working, building a diff, and only making the bare minimum of changes. So this will actually just keep running and adding users. I guess we can look at the end and see how many users it's added. But you can see the render function. It's just so simple. You just say, I have an unordered list, and map each user to a list item. That's it. You don't have to track what happens. We have the add user, and then it's just very simple. You say when a new user gets added, just push it into the state. That's it, and then it'll re-render off. All right. So that was a little bit more complex. We have one more major complex one that we're going to cover at the end. Well, let's take a diversion. So the idea of React is that it's functional. Okay. So when you talk about the definition of a function, the mathematical definition of a function is when you have a function that takes one input and it maps to exactly one output. So if you give the same input, you should not be able to get two separate different outputs. And specifically, I mean, this is almost, if you have that happen, this other part is pretty much going to be true as well. You have no observable side effects. So you're not changing state around anything else. So that input parameter, you don't change the state of it. You don't change it in any way, shape, or form. You just usually return a new item. So a lot of times in functional languages, you have immutability. So that's where, when we were talking before, props are immutable. You need to treat state as immutable. It's because React has functional roots. So a lot of the data you need to treat as immutable. So here's a little digression. I wrote a little page to kind of look at some functional ideas to kind of drive this home a little more. So we have this functional page, and I have this very simple counter. So this is a simple object-oriented way of creating counter in JavaScript. We're going to return an object with count 0 and a next function which increments the count and then returns that count. So you create it and you call next and it'll start incrementing. Then we have a functional next. You pass it a number, it adds 1. So this is very, very arbitrary, but I think it kind of will show kind of the difference between, I mean, I guess functional isn't necessarily anti-OOP, but they are a little bit different. So I just have this function here that's going to create a new counter and then call it 3 times in a row. And then call functional next 3 times in a row. So I'm going to go ahead and load this page. Open up the console. And we are going to run. Okay, so remember the first 3 are from that counter that we called next, and then the next 3 are from the functional next. So you can see the first 3, that is not a pure function. We called it 3 times with the same input, nothing, and we got 3 separate outputs. So that's not a pure function, which, like I said before, by definition, somewhere state is being modified. For that to happen, you have to modify state somewhere. And then the other function, again, it's completely arbitrary, but it is a pure function. We passed in 0, it returned 1. We ran it 3 times in a row, and returned 1 each time. So that is a pure function. It passes through. Now, one of the ideas of having a pure function like that means that you can take the output of that, and then you can actually replace the function, and then in place of that value, and it will work. And that's composability. So if we take functional next, and we know that passing in 0 will return 1. So we want to get 2. So inside of here, we can pass in functional next, and we can pass in 0. And we know that will return 1, which will be passed into the next one, which will return 2. So with absolute predictability, we can say, you call these 2 together, you'll get 2. There is no way that that is going to return 3. So if you think back to our other counter, let's say something else has a reference to it, and you call it twice, and you get 1, 2, and then that calls next. and they get 3, and you call it and you get 4, boom. You know, you expected 3, now you have 4. There's no way this can happen with functional next. If you call 2, and then you take that number and you call functional next again, you will always get 3. There's no way you can get 4. Now, like I said before, this is completely arbitrary, and an example I concocted to display that. But let's actually look at some functions inside of JavaScript right now to show this. So if you have an array, you can call slice on it. So we have a simple array, 1, 2, 3, 4, 5, and then we're going to call slice on it 3 times with the same inputs. We get the same output 3 times. Slice is functional. It doesn't modify state. It did not modify that array. It just went in, created a new array, took out the first 3 elements, and returned that. So that is functional. Now, let's call splice. Uh-oh. We got 3 different outputs back. The first time, it returned what we were expecting, the first 3 elements, but it modified the state of the array. The next time we called it, it only got the first 2, because that's all that was left, and then finally the array was blank. This modifies state. So, this is an actual real-life example in JavaScript of having a functional function compared to a function that is not functioning. So, has anyone here ever used Haskell or like F#? Okay, that's pretty much what I expected.
I tried Haskell once, and I stopped.
Yeah. You look at the syntax and you're like, what is going on? It's very hard to follow. But here's a question. Has anyone used Link in .NET? Link in .NET is functional. When you think about it, let's say like the where extension method. All right? So you have like a list of ints, 1 through 10, and you say, I only want the even ones. And so you make a nice little where clause in there, and you run it. What do you get out? You get a list of ints that are only even. So your initial list, is that modified? It isn't. So that's functional. So everyone that uses Link is a functional programmer, and you didn't even know it. So, and then there's, have you guys heard of MapReduce? That's kind of like the holy grail of functional functions. So map takes a list and it maps it to another type of object, or does something with it. Now if we're talking link, does anyone know what that would map to?
Select.
Yep, select. That's a map function. Reduce is essentially like an accumulator. So if you have a list of ints and you want the sum of them, you would reduce it. It would take the current element that you're on and what the value was before, take those together and return that, which is fed into the next time it runs on the iteration. Now, Link has a sum extension method, so that's a reduction. And it doesn't modify the source list. So all of your Link functions are functional. They're designed to be functional. And if we kind of think about, I don't think Jacob's here, but when he talked about Hadoop, and remember when he talked about Wikipedia and counting like how many A's were in all the articles in Wikipedia? So in Hadoop, you run MapReduce. So what does that mean when we're thinking functional? So you chop it up in a bunch of little tasks. So one of the tasks is mapping. So you say, okay, you're going to take 10 Wikipedia articles, and you're going to take each one, and you're going to map the article to a number, which is the count of E's in it. So you write a function to do that. Now, you don't have to modify any state with that function. You just read it, and you return a number. So you have 10 articles, and then you'll get an array back of 10 ints. And because no state has been modified, you can now chop this up and pass it out in parallel to thousands of computers. You have no worries about modifying the same state, race conditions, anything that you have to worry about with threading, because you're not modifying any state. There are no side effects. So you can chop this up and then send it out to thousands upon thousands of tasks. They can run it, and you'll get all these arrays of ints. Then you can reduce them to an int. So you sum them all, and now you have all these thousands, like 10,000, now you have 1,000 ints. You can chop that up, you can map all those ints, reduce it again, until you eventually end with one int that is a count of all the e's in Wikipedia. And that's done because you've used functional functions. No modifying state, and then when it runs, it does exactly what you expect it to do. You know, there's not going to be anything weird that pops up. So that's kind of my little functional digression. So that kind of leads into our final idea of flux. So when Facebook released React, they said, oh yeah, we use it with Flux. And everyone's like, what's Flux? And they're like, what's an idea? It's not a library. And this is the image they use. And it's the idea that you have your view, which is going to be React, and anything that happens is an action which has to be popped up and come back down through a dispatcher, go through a store, and then come back through the top of the view. So nowhere inside of the view do you change state yourself. You say, hey, this needs to be done. It comes through and comes back through the top. So your view becomes a functional function. You pass it in state, and it will always map to exactly one output. So you give it the same state, you get the same DOM. Because of how Facebook did this, all of a sudden, all these Flux libraries popped up. Because everyone was implementing it their own way, and because it was JavaScript, you know, it turned from like 0 to like 1,000 in like 2 weeks. So there's no like true Flux library. Now I've kind of built some quasi-Flux libraries, some ideas, and when I was doing research to do this, I found one that I really liked, and it's called Redux. And it treats Flux as functional as well. So your state then becomes a series of reduce functions based on the action that happens. So everything that happens in your application is this array of actions. And then you run it through a reducer, which then changes the state. But if you use it immutable, if you have immutable data, you're not actually changing the state in place. You're saying, here's my old state. Here's the action I want to take, which will map to a new state. So at any point in time, if you know the current state and you know the actions taken, you can say with complete predictability what the end result state would be. So that completely simplifies what is happening in your state. And then now remember, we have React, which if we have no elements that use state and they just use props, they're static functions that return the same output from the same input. So we pump that state into that UI and we get the exact UI that we're expecting. So I have one final one that I'm going to run through. I know I'm probably running kind of close on time. Oh, good. All right. So I'll try to go through this. So this is kind of a culmination of kind of everything we're talking about. Now, I added kind of my own, instead of pulling in Redux here, I kind of looked over the source and kind of built my own implementation of Flux so you guys can kind of see what I'm doing with it. So instead of just having like a bunch of library commands that go off into a black box, all the code here that I'm using with Flux, I've put here. All right, so. We have our action constants. If you ever look at Flux stuff, examples, there's always action constants, and you use it exactly why I use constants, so that it's just an identifier, and you don't want strings because you can mistype them. So this is a list of everything that can happen in our application. And it's just going to be a simple little commenting application. So there's our list of what can happen, and now we have our actions. So these are very simple. So we have add, comment, success. So you can add a comment, and then it can succeed or it can fail. So if it succeeds, we're going to bring in the comment and the context, and we're going to return an object that has the type. So that's what we know, what type of action is happening with the data. Now this function is functional. It doesn't change state. You just pass in state, it returns a new object, with the state, does nothing with it. Add comment fails, same thing that happens. So we have this add comment. Now this uses a promise. I don't want to get too much in promises, but it helps flatten any type of asynchronous code. Makes it much easier to work with. So we're returning a promise here when you say add comment because it could fail and it could succeed. And then we're faking a call to a server here. So well, first we have the set timeout, we have a notify, so we're going to let the UI know that we're doing something. We've started this request. Now, you need to send a notify outside the same event loop you're in. If you don't, the notify will never fire. So if you're ever using promises and you have that issue come up where you notify and it never fires, it's because it's in the same event loop that you're returning your promise in. So you can just create a set timeout of 0, and that creates another event loop that notify is going to call. So other than that, we're going to wait 2 seconds, and we're going to do a little bit of validation. So if the comment's blank or the user's blank, we're going to say it failed, and that you need to add a comment and or user, and then we're going to return that back as comment failed. Or if it succeeds, we're going to add comment success. So the comment in the context comes in, and then we're just passing it back through and then returning one of these if it succeeds or fails with a pending off the bat. So this asynchronous kind of adds a little bit of complexity to it, but for the most part, we're still doing very simple actions. We're mapping a comment to just another object that says what type is happening. So pending, we just say, hey, it's pending. Remove comment, we have the index, so this is going to work a lot like the other one. Again, this is a pretty simple application, but hopefully from here you can kind of see how you can build off of these building blocks. Now typing. Now when you build a form and you put an input in that form, it starts off with value of nothing. And you type in it, and that changes. That's a side effect. You've just created state that you haven't tracked. So this tracks all the typing back through because React is going to control what's inside of those input boxes. So as you type in it, it's just going to say, hey, something typed. It's going to go through the flux and come back, and then you're going to get your data back out. So we're still being completely functional. No state is happening unless it runs through our loop. So these are our stores. So this right here is the comment store. So this is our reduce function. So we have the current state, and then we have the action that you're going to take against that state, and then we're going to return a new state. So we just got to switch. If it's add comment success, we're going to take the state, we're going to push to it. Now, this is immutable because I'm using a library called immutable, which is built by Facebook. So when you modify anything in that object, it actually creates a new object for you in place. So this is not modifying state in place. This is an immutable push. So you still have the previous state, and you have the new state. And that's what's being returned, that new object that pops out of that. And then if it's remove comment, we run it, and if it's not anything we worry about, we just return that same state. So when you think about what a reduce function is, it takes the new action that's coming in and that current state, and it's going to return a new state. When you're thinking of sum, you start with 0, you start with the new number that comes in, 1, you say add them, and you return 1. And then that gets passed into the next one. So when you think about that like this is just a reducing function, which is functional. And then we have the form here. Now we have the context. And looking back at this, I should have wrapped the whole thing to check the context first. But what this does is, in case you have multiple forms that are adding, or say like an AJAX request, you want to make sure that you're not changing the state of the form when an AJAX request comes in, and you'll see that. So this is where I was talking about with immutability. So we need to change like 4 properties off of this. Now each time we change a property, that's going to create a new object. So to do this, we would have to store each iteration, or you run this with mutations, and it lets you mutate the object as many times as you want, and at the end it'll return that object at the end, if that makes sense. So each time we run this set, that would create a new object. And if we use the state again, we would only be changing one piece at a time, and we would not get all the changes at the end. So this is just an implementation detail of running immutable.js. But what we get here is a new state object with these changed. So if the comment fails, we're going to put the error out there. We're going to say that the pending state is done, or request is finished, and that it's going to pass in the comment and the user that you passed in before. Again, we're tracking all of the state of the form here, because we don't want our UI to track state, because then you start getting into mutations, and your state can get out of sync with what you expect it to be. So we don't allow the UI to do anything. And then we have pending, we're just going to say, hey, the request is currently pending, it's not done. And if it's a comment success, we're going to blank out the comment, and then we're going to blank out the errors. And in typing, we're essentially just going to send back through. And if it's none of these, we're going to return the state. So here's immutability. So what I was talking about before, if you have a list, we just say immutable list. And now anytime you modify that list, it's going to return a new immutable object each time you modify it. And then for an object, you're going to create a mutable map. Same thing, you modify any of the properties, you get a new object out. So this is kind of the implementation details of that Redux that I was talking about. Now this is heavily influenced by it. I've kind of implemented it kind of my own way, and definitely it needs to be refined. Because I pretty much wrote this leading up to this talk for this. So we have get state, it just returns a state. We're going to start our initial state, we're just going to set it to the initial. And now our store, because remember, we have state and store is our reducing functions. So store takes a current state and an action, and it returns a new state. So these are our functions that we're going to execute on our state. So we have our initial state, how we're going to kick off, then we have an init, which we run on our store. Here's a list of all the actions we can take. This action creators, there's a lot of binds in here. Essentially what it does is it creates you a function that you can execute outside of the context of Flux that still executes in the context of Flux, if that makes sense. Now again, this isn't really required to understand with what we do. I'll show you what this allows us to get at the end. And in handlers, it's just a simple paradigm. You have an array, and you can set a handler, and it'll be called later. This old state stuff, I'll demonstrate when we get to Flux, but it's not really required for here. Now these are the key functions. So we have dispatch. So you have an action, and now you have to tell it to run against your Flux. So we're going to dispatch that action. Now it could be a promise, so we're going to resolve it. So if it's a promise, we're going to wait till it is resolved. And if you resolve a promise and it's just a literal value, you just get that value out. So this works whether it's a promise or not. And then if it's successful, we're going to call handle dispatch, binding this on it. The next one is if it's aired out. We don't really have an example of this, but you could write your own handler for that. Or if it's notified, we're going to call handle dispatch. So handle dispatch is where the key part of what changes happens. So the key part here is where it says object keys, this store. So it's going to take the store, and for each key, which we have a comments key and a form key, we're going to map over that, and then we're going to execute. We're going to take the state, which it matches. Remember, we had a state comments and a store comments? So we're going to take the store comments, we're going to execute with the current state and then the action that was passed in. And the output of that, we're going to map back to the state. Does that make sense? So we're running that reduction function, taking the current state, reducing it with our store, which is going to look at those actions. For example, if we were doing comments and it was an add comment success, and we executed this, that would then execute a state.push. So whatever the array was, we would add a new element in that array and return that new array. So if we had add comment and there was a comment in there, this handle dispatch then would execute against that and then return that. Now, remember, we have default on all those switches. So if you don't handle this action, you just return the same state you had before. So nothing has changed. And all the states that existed before still exist because they're immutable. You haven't modified any state whatsoever. Yes?
But maybe I'm missing something here, but when you're mapping across in the lambda you're passing to the map,
Yeah.
you're overwriting the state. Is that still valid within the rules of
Yes.
immutability?
It sounds like the mutation.
I was to say that right there. That was like okay. Follow
Yes.
and say Garrett. That sounds like you're
Yes.
breaking the rule there.
Yeah.
Yes. So, somewhere you have to mutate state. But that is the only place that state is mutated at all in this application.
But
So it is still
technically-
considered a mutation.
Yes, yes.
Okay.
Because it's
I was
different
like,
than what it was before.
that's
Technically, from a functional standpoint, you're not though, because at the end of any functional operation, what you pass into the next thing is the state for that item. So you're just taking your end state from the first transaction and passing into the next
Yes.
transaction. So you have your state bundle, just like you would in Scheme. The output from your function is the input to the next function. You didn't mutate state, you just gave that next state.
Yeah.
you're just sticking
It's
it
initial
somewhere so that
state.
you can carry it on to the next
Yes,
operation.
because we're using immutability, so we haven't modified, when we did a state push, I didn't change that list in place. That other list still exists, and then this is here. So, if it goes out of scope, it'll get garbage collected. But if you keep it somewhere, you then have that old state as well. So, then we mapped to the handlers. So we went through every store and every state, and we've modified it, or I should say, ran it through its reduction function to figure out what the new state is. Now again, for most actions, this means the same objects return, because you only respond to a couple actions. And then we're going to call each function that we've registered and said, hey, return the state that I just grabbed from our reduction functions. And then that save state is where I was talking about before, which we'll get to here in a second. So this is a flux. So again, like I said, this can be cleaned up a lot more. I just kind of put this out here, and it's heavily inspired by the Redux. The whole idea of having your actions as just simple objects and your stores as simple reduction functions is the key parts right here. That's where you're not modifying state anywhere. Okay, so here's our user image. We don't have to run through this. It just uses props. So here's a comment. It's just going to take, it's going to return a div, which has a div with the comment, and a span with the user image and that user's name. And if you look at that, those are all props. No state is being modified in this component. It's just going to completely remeasure what you pass into it. Now, that's a perfect unit test right there. You pass in props, and then you see if it does exactly what you expect it to. Comment list. This right here, we're going to take all those comments and then map it to an unordered list with each comment as a list item. And then that list item inside is going to render that specific comment. You see that right there? So it's going to add, it's going to call React create comment with the comment. So you're going to have a list item with each comment. Again, we're building this, we're composing it by building simple little functions that are functional, and then we're using them to build a bigger whole. And then here, we're going to bind remove handler. So we're going to have the index, so when you click, but you notice, it's still not calling set state. It calls this props remove handler. So that handler is passed in from above, and then it just executes it. So that's what I was talking about before with events. You don't have to modify your state in place. You can then have an event or a function passed down to you. Because with JavaScript, functions are first-class objects. You can pass it in as a parameter and then use it later. And then the whole thing where I talked about it binds in the context, by doing what we're doing before, that allows you to call, this right here as remove handler. It's a function, and it's going to bind that index property and then execute that function with the context of index in addition to the context of flux. If you want, we can talk about this after, but I don't really have time to really get into how we bind all that up. But that's how we're adding this remove handler and then calling it this props remove handler. So here's the form, and then this has a submit handler. When you submit the form, we don't want it to refresh the page, so we're going to prevent default. Again, that's just your common JavaScript event object passed in. So here we have flux handlers because we're going to call multiple. So we're calling add comment. Remember, that's one of the actions we add. You can add comment. So this is saying, take the reference of this DOM node, and then down here, again, this I kind of introduced a couple things, but based on time, I'm not going to go really deep into them. You can create a reference so later you can easily recall that object. So we get the DOM node, we get the value for comment and user. We call add comment, which remember that's a promise action. And then we do the comment handler, which is tied to the input for comment. So every time you type, it's going to kick off an event and it's going to come back through. Same thing with user. It's just going to take that value and it's just going to pass it back through your reduction function with comment or user. And then here is where you can kind of do some stuff. So if the form is not done, I'm going to change the text on the button to say leaving a comment now or leave a comment. So when you put that form in a pending state, it's going to say leaving a comment now. Or it's going to say leave a comment if the pending state is done. And then as you can see here, we're going to render the errors as just a simple map. I'm just going to put a div with each error in it. Because remember, our errors are just an array. Again, this is really simple. And we're going to have one input box that is comment, another input box that is user, and then a submit button. And if we pull these over, you can see that we have on change. If you go to the React docs, it'll have all the events that you can listen for and fire on. So each time you type, it's either going to call comment handler or user handler. And it's going to take the value of the state, which is props form, and we're going to get the comment attribute off of it. Again, I'm kind of going through this quickly because I know I'm kind of at the end. If you guys want to know more, just come talk to me after. So this is the top level comment component. So all those before, if you look at them, there is no set state on them. They all use props. So nothing is modifying state internally of each of them. So we have this comment component, and now this has a set state. But if you notice, all it does is use the flux set handler. So every time flux changes state, it's just pretty much a proxy to this to change the state. So again, even though this has a set state, that's just the catalyst we're using to re-render everything underneath. And you can see here, we have a div, which returns the comment form, which are flux handlers, that action creators. When we execute that, that's how it binds the context of flux right there. And then we see for form, which is a state of the form, we're calling get state, and then just return the form element of that. And then the same thing with the comments. So we just return comments as a state, and then this only needs one of the actions, so we just return that action. So if you look through it, at this point, everything essentially has been props except for set state on this top level component. And then we render the comment component. So right there, React render, comment component, and all we pass into it is at flux. Because that has all of the abilities to change state in and of itself functionally. So we pass that in, and the top level component doles out, you get this state, you get this state, you get this action you can have, you get this action. Now I will admit this is kind of one of the downsides in that if you have a tall hierarchy, it becomes a pain in the butt. Because if you have something 5 levels down that needs an action, you have to pass that action down 5 levels. That is kind of a pain in the butt with React. But again, hopefully if you look at the actual render functions, they're very simple and straightforward. Now here, then I have this set timeout. So 3 seconds. This is like an AJAX call or a socket IO, some event that fires that say, hey, there was a new event. So it's going to pass it in. It's going to say flux, dispatch this action, add comment success with this value. And then we put a context of AJAX. Now if we didn't put a context other than form, what would happen is it would modify the state of the form because it'd see that add comment. Because we have actions that can run on different contexts. So again, if I was to rewrite this as a library, I'd make that easier to implement than what I've done here. But like I said, I kind of pumped this out really quickly. So we'll go ahead and actually look to see what this does. So there it is. So if we remember what our init state was, which was a while ago, we had test air from init, and then we have from init, and then the user could be anyone. So there's our set timeout. So we see it called, it drew it on there. So I'm going to try to leave a comment, and you see it change the button, and it changed the state. It cleared out the errors, and then it waited 2 seconds, executed that function, and said, hey, you need a comment and or user. So I'm going to add a comment, try to leave a comment again. It tells me no. So again, we're just using those like 4 or 5 actions and executing them against our flux. So now we're going to add everything, say leave a comment, 2 seconds go by, it worked. You know, same thing, you click on it, a list item, it's going to delete it. So now this is where using, okay, so the gravitars weren't pulling in. So this is where using something like, remember how I said we had a save state? So each state change, I've actually been saving. So if we look at here and look at the object, we can see comments. So this is the implementation of the immutable. We can see it's an array with 2 in here. And then same thing down here, we can see that here's the action, here's an object, Ajax, add comment success, and we can say here's a new state that has been pumped out. So we've actually saved every state element from here. And now inside of Flux, I have this function called apply old state. So I can say, take me back to state 0. So that was the state at state 0. Then I can say, well, show me state 1, what happened? So the next action was that Ajax one came in. And then let's say, what's the next action after that? That was me executing that, so it's in a pending state. Now I can go in here and jump to 10. So actually that was me typing, because you see I don't have Josh all the way in there. If I go back to 9, you see it's JO. Because I'm tracking every mutation happening through this, and I'm saving it. Because remember, our state is functional. So when you run that action on it, you haven't mutated the current state, you created a new state. And the same thing with the output. So now that our UI is completely functional, you give it the same state, you get the exact same output out. Which is great, say, if you have an error, you just log the state, or say log the last 5 actions and the last 5 states that were there with your error, and now you know exactly what happened in your application and how it looked at the time that error happened. So that's why I like React. And I don't have any more.
I do have one for you. So, because I really want to ask this, so I want to make sure we at least get this in and a couple others. So I'm sure some people have some questions. But I know people probably need to get going and whatnot.
Yeah.
With all of this state tracking, what about memory management and all that? Like, eventually, I know we now have computers that have 16 gigs of RAM, but we have to actually use some of that for other things. Did the Flux implementations kind of like have like an LRU, like at a certain point things start falling off?
Yeah, I would definitely say you would need to worry about that, especially with React. React is kind of heavy as well. It's not like pulling it in. You're definitely going to. It's heavier for what it does because it actually does a lot, even though it's just the view. So that's going to put a little memory management on you, and especially if you're saving those states. Yes, I mean you can say I only want to store X amount, and once they leave any references, they'll get garbage collected. But I mean that's not. Depending on performance, you don't want to say, well, I want to garbage collect 1,000 items every couple seconds. So yes, that would be a concern. This definitely, I would say, is you can use it in mobile, but you would definitely want to worry about memory management in mobile. And then with the desktop, yeah, you definitely worry about memory any way you look at it. It's more about simplifying how you think about what you render.
To add to that, if you only keep the inputs, then you can just recreate the state on the fly. That's what StarCraft does.
Yep.
For the replays.
If you store all the actions and you know the initial state, you can end up at any point along that.
Yeah, so then you don't have to store the state.
Yeah. So I was doing that just so it was simple. The actions are there. Like I have a replay action, but it doesn't reapply the state at that point. Like if I say replay action 1, which if I'm not mistaken, is like the set timeout. So it should add a set timeout to it. So you see that? I just replay the same action. So that list of actions, if I started with the exact same state and I applied those, what are we up to, 15? Those 15 actions in a row, you could watch the state change. Sure. So I mean, that's one way. Yeah. Any other questions?
So what does the memory look like on your add user one that was running in the background? Just a fairly significant amount of state.
Oh, which one was that? Was that state?
Yeah. I just saw green.
Yeah, it's adding every 10 seconds. Let's see, right? That's not too bad. Although this isn't storing state.
Oh, that's true.
It's
Yeah.
just one list.
Yeah.
So it's modifying state internally, and it's just strings. So
What's
not
the
too bad.
snapshot on the Flux one?
Let's see here. Still not too bad. But I mean, we've only had 15 states. Any other questions?
I just have a comment.
Yeah.
It seemed like when you were going through all the programming, I was, in my mind, thinking of Facebook and how it works. So you have your comments, you have your user profile, things remain the same.
Yeah.
And then when you have when you refresh, you're taking your virtual and putting it into permanent or going
Yeah.
from virtual to your, what's that word used?
The virtual DOM or?
Going from, virtual to the actual.
Oh, yeah.
On your refresh.
Because you have what's on the
Right,
page.
right.
Yes.
And then when you go into like creating things such as pages or groups, and you're creating this other, what's the name? You had a different.
Well, you can also render. I was just using one React group. You can have multiple because you can
Is
render.
that parallel to what you were
as
talking
many.
about?
I think, yeah, from what you're saying, so like you can do things like you can, hydrate like an array or something or some object and use that as initial state. React is isomorphic. They have hooks for Node, .NET, Python. So you can render already on the page a React thing. And in fact, they have React Native, which works on like iOS and stuff as well. So they've really been building this out. So I think that's kind of along the lines that you're saying as well, is that like you have this, and it will actually look at the HTML and determine what the changes are. So if you already have HTML there and you render a new React and it's the same, it won't take any action because it says this is exactly what it should look like.
So then you're not looking at using React as a tool to build whole pages. You'd be looking at it for specific sites and spots on the site where you wanted replayability or tracking of user functionality, or you had very DOM-intensive tasks that you wanted the limit to be very precise in their updates, correct?
Yes, you can use it for things like that. I mean, you can use it for either sections, because you can componentize your application. So you can say, well, I have this, and I just want to use this part as React. You can just render that part in React. You don't have to do the whole tracking state. That was just kind of a little example of things that you can do once you've abstracted the idea of using Flux like that and the functional UI. But yes, and in fact, Khan Academy, they started using it because they had issues with when they rendered certain things, like you change one character, like for math examples, and they'd have to write it out, with math notation, and it would re-render the whole thing. So they started using React, and it would just render that little part of it. So that's really why Khan Academy, they used it. So, render-heavy things, you can use it. But I mean, it definitely excels in some parts, and depending on what you're doing, you could have issues. Just like any tool, you got to try it out and see how it works for you.
It was slow than it did before.
See, what I don't get with all this stuff is, take images. If you just use SVG, you wouldn't have to be doing all this, I call Rube Goldberg stuff to make things work faster. I mean, we're building a site right now, there's no JavaScript. It's all native HTML5. I only use JS for one, Java for one thing, and it's not script, it's on the server side. But this other stuff, it just, first of all, you don't tell the whole story of Facebook. What service are they running?
Yeah.
They're not running Apache, okay? What database are they? They're not using MySQL database. So, you know, there's a lot of things that go in. If you're going to use React, you have to use probably a NoSQL database. Because you're not going to be able to
I don't know if
do
that
this.
is, but I mean, we can definitely discuss that after, because I know it's getting late. I think Rob wants to wrap up. But I mean, if we need to, we can talk about that. So,
Thanks, John.
all right.